discussing graphing linear quadratic systems. So let's start with a review of graphing linear systems. So a linear system being a set of two or more linear equations, and we're going to graph them on the same coordinate plane. So my first one here, I've got y equals 3x minus 8, which tells me I've got a y-intercept at 8, and my slope of 3 tells me to go up 3 and right 1. Whoops. Okay, and then I can draw in my line. For my other equation, first thing I need to do is put this into slope-intercept form by subtracting x on both sides. So y equals negative x plus 4. Now I've got my y-intercept at 4, and my slope of negative 1 tells me go down 1, right 1. And then I can draw in my line here. And my solution to this system is the point where my two lines cross right here at the point 3, 1. So that's a linear system. And the only thing that's going to be different today is that now instead of having two linear equations, now we're going to throw a quadratic equation in there. So a linear quadratic system is a system that's formed by a linear equation and a quadratic equation. And when we want to look at their solutions, there are three possibilities. They can have two solutions, one solution, or no solution. Okay, two solutions being that our lines cross at two places. One solution, our lines touch at one place, and no solution where they just never cross at all. So the process is that we are going to graph both of our equations on the same coordinate plane. And then we're just going to look for where the two graphs intersect. It's the exact same process that we would go through for graphing a linear system, but we're just throwing a quadratic in. So let's do this problem. So I want to solve this system by graphing. I'm going to start by graphing my linear equation just because it's easy. Y equals negative x minus 1. So my y-intercept is at negative 1, and my slope is also negative 1. Remember, the more points you use, the more accurate your graph will be. Okay, that should be good enough to draw in my line. And so now I need to do my quadratic equation here. So I'm going to start by finding my vertex. Okay, remembering my formula for vertex is x equals negative b over 2a. So in this problem, that's negative 4 over 2 times 2, which is negative 4 over 4, gets me negative 1. And then I need to find the y value of my vertex by plugging negative 1 in. So I've got negative 1 squared plus 4 times negative 1 plus 3. If I work all of that out, I get negative 1. Okay, so my vertex is going to be at the point negative 1, negative 1. So I'm going to plot that right here. Okay, so a couple more things I can find. I can use my y-intercept of 0, 3. Because that's two spaces this way, I could go 1, 2 spaces this way, and they'll have the exact same y value. And then I also like to find my roots. Okay, so for this equation, we can factor this. X squared plus 4x plus 3. 1 times 3 is 3, 4 is on the bottom. Two numbers that multiply to 3 and add to 4 are 1 and 3. Use our factoring shortcut. Divide by my leading coefficient, but make it negative, so divide by negative 1. I get negative 1 and negative 3. So my roots are at negative 1, 0 and 3, 0. So negative 1, 0, and 3, 0. Got 5 points, which is enough to graph. Do my best to make my graph as accurate as possible. And we can see that in this case, this has two solutions. Okay, it has a solution at negative 4, 3. And it has another solution at negative 1, 0. Okay, the solution is just being where our two lines intersect. Take a look at a second example here. So I've got y equals x squared plus 2x plus 3, and 4x minus 2y equals negative 6. I'm going to deal with my linear equation again. So I got to put this into slope-intercept. I'm going to subtract 4x on both sides. Negative 2y equals negative 4x minus 6. Divide everything by negative 2, and I get y equals 2x plus 3. So my y-intercept is at 3, slope of 2. Then I can draw in my line. For my quadratic, well, let's see. Let's work on our quadratic down here. Find my vertex first. So negative b over 2a, negative 2 over 2 times 1. That's negative 2 over 2. That's negative 1. If I plug that back into my quadratic equation, got negative 1 squared plus 2 times negative 1 plus 3. And if I work that all out, I get 2. So my point is at negative 1, 2. Which is close to my linear equation, but it's not quite there. Use my y-intercept here at 0, 3. And because that's 1 away, I can also go over here and use negative 2, 3, because they're symmetrical. Okay, this equation is not going to have any real roots. It's not going to have any solutions. So I'm not going to worry about that, but I do need to find another point. I'm going to plug in 1. So I'm going to go y equals 1 squared plus 2 times 1 plus 3. That's 1 plus 2 plus 3. That's 6. So I can go to 1, 6. I can also go to negative 3, 6. And I can draw in my equation, or my parabola here. So we can see this is a problem where they intersect exactly one time. So my solution to this problem is just that one point where they cross at our y-intercept of 0, 3. That's all there is to it. So I will leave you, as always, with